in this episode.
LLMs really are just a statistical pattern matcher trained to generate coherent sequences of text without an intrinsic understanding of the world. And so, cognitive computing partly is what leads you to building an LLM. It's like, how do we understand how the mind works? Let's apply this to a version of computing. However, cognitive computing is a very broad field, and as a field, we've sort of moved away. I feel like most scientists are saying basically LLMs are not going to lead you to AGI, and if you're still trying to create a cognitive system, you are more and more going towards the idea of agency. So the model has to have a model of itself and the world. It has to continuously update its beliefs, act autonomously. And so an LLM really isn't an agent. It simply generates responses based on next token probabilities. And so it doesn't really minimize uncertainty about the world or engages in adaptive reasoning. So while it could be, an outcome of cognitive computing, they're not a cognitive system in themselves. And so I think generally we are moving on from LLMs.
Hey everyone, welcome to my conversation with the cognitive computing researcher Mahault Albarracin. Active inference is a way of understanding sentient behavior. In short, it puts the action into perception, whereby perception is treated as perceptual inference or hypothesis testing. Active inference goes even further and considers planning as inference, that is, inferring what you would do next to resolve uncertainty about your lived world. Mahault is a researcher in the active inference cadre working with the likes of Carl Friston and Maxwell Ramstad. She's done work in the intersection between sociology, Husserl's phenomenology, machine learning, and physical mathematical theories like the free energy principle and predictive processing. Furthermore, Mahault also researches what I'd broadly call physics-inspired social sciences with papers such as epistemic communities under active inference and designing ecosystems of intelligence from first principles. In this episode in particular, we discuss what fundamentally differentiates agents built on the principles of active inference AI and cognitive computing from the current LLM and transformer-based AI paradigm, while also exploring some fascinating concepts in neo-materialist philosophy, emphasizing the active and relational nature of materiality. And now, with all that being said, a quick PSA. As you may know, I've mentioned multiple times, I'll never have advertisers or sponsors on this podcast. Frankly, I think we live in a society of excess and overconsumption, and I don't want to contribute to that by selling you more things. That being said though, forgive me for the tautology. We, for better or worse, live in the world we live in. I run this podcast on top of doing a full-time job while doing my master's, and if I am to sustain this project, I need some kind of financial backing. So if you have the means, please do consider financially supporting this podcast through Patreon, Substack, or PayPal. All the links will be in the show notes. And if you're wondering, what are the perks? What are you going to get? The honest answer is nothing. That's right, there's no exclusive behind the paywall perks. You're simply supporting this project if you think the already free content that's publicly available is of any value to you. I sincerely do want to thank the existing supporters on Patreon, Substack, and even PayPal. However, if you're considering supporting the project, please do so only if you have the means. Alright, back to the episode. Mahault Albarracin is a PhD student at UQAM Montréal, Quebec, researching cognitive computing and social sciences. Mahault is Director of Research Strategy and Product Integration at Versus, a cognitive computing company. She's also an IEEE Fellow, author, lecturer, and has an MA in sexology. With all that being said, here's my far-ranging conversation with Mahault Albarracin.
Awesome, Mahault. Thank you for being here. As I was saying, I've been following your work for a bit. Really do appreciate your time today. I know you've discussed this in previous interviews, but I thought, why not just ask it again to see where you're at right now? But perhaps I'll formulate the question this way. So as we were discussing prior to recording, you started off in a background more in sexology, somewhat of the, let's call it sociology even, and now you kind of step into this realm of cognitive computing, which we agreed on discussing today. But yeah, I mean, in hindsight, or perhaps in retrospect, if you could reflect on kind of your career trajectory to where you're at right now, yeah, how do you think you went from studying something more in the humanities, like sexology, to something a lot more in the empirical naturalistic sciences, like AI and cognitive computing?
Yeah, so I mean, if you know how sexology is built, it's not really a science, it's more an amalgamation of different fields that is focused on a topic. But in order to understand the fields, you have to have a very wide education. So you go on the basics in sociology, psychology, anthropology, biology. You do quite a rounded study. And then I went into the master's and I went even rounder. Like we were studying gender studies, we were studying media studies. I learned to do statistics because my master's was meant to lead me towards a PhD. So we had to learn how to do qualitative and quantitative analysis. So it was a very, very broad program. And while I was doing that, I also had personhood. So I was involved in a variety of communities and I started getting interested in topics they cared about. And I found that there were so many sort of confluence between the different fields that it started to really hit me that there was this underlying structure that I could taste it, but I couldn't quite express it because none of the fields exactly had the right tools. The way I was seeing it at the time was through Lego sets. Like I was thinking of ontological pieces that you could sort of map together. And that freaked out my professors. Like they hated it. They were staunch adversaries to my ideas. So then I finished my master's. I did what they wanted. I published a book anyway with the rest of my ideas that I couldn't put in my thesis. And then I started reading more and more about predictive processing, which was en vogue at the time. People were starting to pay attention to it. And I realized that that's exactly what I had been looking for. It was the right formalism for me to put my ideas together. And that led me to active inference. I had already learned how to program because I built a company. I learned mostly web development. I was a full stack developer, but I now wanted to move into artificial intelligence, where to me was the most interesting aspect because I came from this field where it's heavily geared towards cognition. And so just web development wasn't really scratching that itch for me. So I went into the PhD for cognitive computing. I spoke to a few professors about my ideas, and then they led me to meeting Carl Friston and Maxwell Ramstad, and we developed our ideas together. And so that's how I ended up where I am.
Yeah. So if I could ask, I'm curious to hear, as a scholar, would you consider yourself more working in the realm and kind of the philosophy of mind, or do you think you're more like a person working more in the sciences, be it neuroscience or cognitive science or AI, something that's a bit more, scientifically grounded?
So it's funny because to me, philosophy is not at odds with something being scientifically grounded. I think the only difference is the means by which you accept that potentially you can apply a truth value to a statement. And oftentimes I find that a lot of philosophy that I've read was based off of people who had done empirical research. So they just had extracted what they believed to be some more fundamental truth that they could sort of rely on, or they base their ontology on that. So I don't think these things are mutually exclusive. That being said, because my background is in social sciences, and social sciences tend to be perceived as, on that edge. Like people tend to think it's not really hard sciences. It's not quite philosophy.
Forgive me for the interruption, but I've actually stopped using that term, hard sciences, soft sciences, because it's a misnomer.
Exactly. No, I completely agree. To me, the scientific process has more to do with the way that you're able to place a measurement, any kind of measurement that leads you to a conclusion that can be falsifiable within that frame. So even you can even do falsifiable qualitative research, right? So it's not. I think it's more about the process and the ability for this process to be replicated and validated by other people, such that they may come to the same conclusion. So it's this repeatability and falsifiability that's important. So I don't know if I fall strictly anywhere in particular, because I engage in a lot of theoretical work. I've had a lot of discussions with other people on the way I view cognition, and in general knowledge production has more to do with the network you are part of. I don't believe most cognition happens in only one node. So I'm not a neuroscientist. I don't think that's not how I've been trained, but I've worked on topics that were related to neuroscience. I've done simulations that were related to that as well. So I think I fall in empiricism. I'm able to produce verifiable outputs that can act as empirical, data. But I don't see this as non-philosophical.
Yeah, it's interesting. I mean, we're not probably not going to discuss it today, but probably one of your most popular papers, the one epistemic communities under active inference, and you said that whatever discipline you're involved in, it's really the network that you're a part of, that you're situated in. And in that paper, you even give like an active inference account of this kind of epistemic communities, as you call them. I'll leave a few links in the show notes to some interviews you done on that. Okay, so before we get to cognitive computing in particular, I'm also curious to hear more about your philosophy of science. And the reason I say that is because obviously, I finished your Husserl paper a couple of weeks ago, but then I was just reading. I couldn't get through the whole thing. This recent one, shared protensions in multi-agent active inference, and then one thing you've done is you and your authors, you guys have tried to unify Husserlian phenomenology, the active inference framework in theoretical biology, and then use category theory in mathematics. Now, could you, again, sorry for this big, grand metaphysical question, but I'm just curious to hear where you come from. What is your ontology of mathematics? I mean, are you like a mathematical realist? Are you a constructivist? How do you account for this? And the reason I ask this is not just because like a fun, philosophical question, but like a lot of the work, of course, you do, is like the formalism is done in mathematics. And therefore, I think it kind of makes sense to just ask this question as to how you view the role of mathematics in your work as a scholar and your colleagues and peers, of course.
Yeah, absolutely. So I fall into the school, I think, of agential realism and neo-materialism. And I think that has implications for a lot of the work I do. And there's been papers written about this. For example, the map territory fallacy by Dalton Duval and again Maxwell Ramstad, where they touch on some kind of these ideas. But Avel Guénin-Carlu also does some work related to this, where we lay out these ideas. But basically, I'd argue for a sort of hybrid or structural realist position, because I feel like strong realism is a bit hard to justify because of the history of scientific change and many things that were once believed to be real theories have been abandoned. But I don't think we can really engage either with pure non-realism, because it seems implausible that science doesn't track anything about reality. Active inference would argue against that. And I think pure instrumentalism in itself also is sort of too weak, although even we could argue that active inference lends itself to instrumentalism, because it is all about ultimately making predictions. But I do think it uncovers deep structures. And so for me, it really would be about a middle ground between this scientific realism and non-realism, by focusing on specifically relations rather than isolated entities. And so I don't know if you know a bit about agentic realism. Do you want me to expand?
I'm familiar with the concept, but if you could maybe perhaps explain it.
Sure, absolutely. So it was formulated by Karen Barad in 2003. And so basically this was a response that she thought was important to naive scientific realism, which basically assumes an independent, pre-existing reality, which I have a bit of a problem with, and sort of radical social constructivism, which, as you mentioned earlier, the work of Foucault, etc., it denies an objective grounding. Like, for example, I can't get behind Derrida, I just can't. But I do see where he's coming from. All these questions of metonymy are speaking to something. And so I think ultimately there is no measurement-independent reality, but that doesn't mean there is no reality. There are phenomena, not specifically objects, and phenomena are the fundamental unit of reality. So measurement does not just reveal reality, it really participates in its becoming. And so the experimental apparatus aren't just neutral observers. They shape what is measured. And so the structure of reality emerges through the interactions between the systems, so the experimental phenotype, and the world. And so, yeah, I think the key important thing here is that what becomes important is the repetition of measurements and how different types of measurements as a sort of mosaic will say something about a deeper structure of the relationship between the possibility of measurement and a structure. Does that answer your question?
It certainly does. I mean, let me ask you this. I don't know if you still hold this view, but probably about a year ago in one of the interviews, you said that with your interest or, kind of you were looking into Slavoj Žižek's work, and you were like, oh, what he's trying to get at is that the real, at the end of the day, it's like nothing. There's nothing there. And then, in some sense, you were saying, yeah, look, all reality is a type of social construction, but that doesn't mean it's like a solipsistic, or from my mind, I project everything onto reality. It's not in that sense, but there is something where you can't really get let's use like of this big philosophical term, the subject out of whatever discussion we are having about any kind of Weltanschauung or any kind of like big grounding philosophy. I mean, would you still say you subscribe to that notion that, like, at the end of the day, there's nothing behind the veil, so to speak?
Sure, I subscribe to this. I think the idea has there is a degree to which it has merit. But I think it's because we're operating on a scale of perception that is just an emergent aggregation. And so that aggregation is nothing. It doesn't exist. And so if you kept trying to figure out what's behind, eventually you get to a level where by losing that superstructure, you've lost the emergent properties of the superstructure. So it's breaking down into something which just isn't there anymore. So that's why I think there's a degree to which reductionism is limited. I think active inference is an interesting principle or paradigm because it allows us to think with the same tool set throughout all scales, but you're still missing this component of what gives you the historicity of the system, what gives you the exact structure of the system, and that ultimately is not something you could simply pull down from. Like there's no one driving phenomenon that will give you to the core of the thing. I mean, obviously, I think what Zizek gets to is a little bit deeper than that. I think he's going a little bit more into psychoanalysis and, like...
Yeah, neo-materialism and this whole thing,
Yeah. So I'm not saying I'm going to go all the way there, but I do think that I've read some physicists where they sort of get to the same idea with renormalization, where you can always, keep going deeper and deeper and deeper and ultimately never find the point. You just keep shrinking and the thing keeps eluding you. So I think there's a powerful truth there, but it's not necessarily that there's nothing around you. I just think that the thing we're looking for might be the wrong question.
That's fair. That's fair. I mean, I don't know if this is like a naive way of putting it, but the way I see it is that like what you're saying now is like, okay, if you take McDonald's, sorry, we call it Macca's here in Australia, McDonald's, yeah, like you take the individual parts of the McDonald's system, you know, preparing the burgers, whatever, the ordering system. I mean, you can't point at like a piece of lettuce or like a patty and be like, that's McDonald's, right? Like something broader that emerges. And that's kind of what, like, at least for me, one example here would be the kind of work you and your colleagues are doing with within your world of FEP. Is like the interesting thinkers always, they point more at like this kind of relational based systems that way you can't like point at one solid thing and like be like, oh, this is it. This is the thing that is the thing. And it's funny, like in the history of philosophy, you know, people like Aquinas, whoever, they try to like point at God, right? Like the unmoved mover as per Aristotle. So it seems like there probably is some psychological point here where we have this unyielding desire to find the thing, the solid thing that kind of connects it all, brings it all together. And I think Zizek uses a Lacanian term called the big other that holds it all together. But so far, at least, we haven't found it.
I mean, haven't we? Isn't it entropy ultimately?
I mean, there you go. Probably, yeah. Which is like a funny kind of big other, like it's like entropy, you know. So
yeah, I mean, I feel like the reason we have this need to find a tangible causal link is because that's it, right? That consciousness is literally that. It's tracking the cause. And like, if you need to track the cause, uncertainty around the cause is highly, you know, activating, because you're never quite like reaching the point you're in. Something could always come out of the woodwork and, I don't know, annihilate you, just make you into a soup. And I feel like that feeling that this is tangible, this is the thing, this is the cause, it's certain, it's as certain as my senses are, right? Like that's why we are so fond of materiality. That's why abstractness annoys us, and that's why we create all these effigies and icons, because entertaining that divinity is like, you know, this abstract concept in the universe. It doesn't help. It doesn't help. However, thinking of a deity as a person that you could have seen and it has a face and in fact it looks like someone you know, like that's helpful, right? Like that really feels like it. You can actually like, oh, okay, I get this. Like this is fine. This is tangible. So I mean, I think there's something profound there, but
100%, yeah, a lot to think about and speculate on there. Okay, I mean, before we get to, again, cognitive computing, I think one last question just to lay the groundwork here. And look, I feel like most people that click on this episode will have an idea of the kind of the work you do on FEP and active inference. Therefore, I'm not gonna, you know, since you probably do this in every single interview, go through what is active inference. I mean, you know, Google it, read a book. Don't be lazy to the listener. But I'm curious, how much do you think FEP, let's talk about FEP for a second, because, you know, active inference is like a corollary of FEP. To what level do you think you can push it? Like, can FEP be like almost like a fundamental principle of the universe itself? Is that a claim one could make? Or is it better to keep it at like explaining the mind, sentience, at more of the, let's call the anthropocentric level?
right. So the FEP itself, I mean, it's not inventing anything new, right? It's just thermodynamics. So that's, I think that's already a fundamental principle. But active inference, that's something that could technically apply to everything, because everything can be understood as a special case of it. But do you really need to? Like, some things just aren't useful to cast under this light. You might not need to cast a rock under this light because a rock isn't really engaging in an active, loop. So while you can do it, it's not going to tell you anything new, because in order for it to be applicable, you sort of have to abstract away some of the things which make active inference interesting. So it's better to use it for living systems, and living systems can start very, very low, right? You can start with bacteria. And so if you start all the way down there, and then you extend it to self-organizing systems, now you've got something really interesting, right? What's a self-organizing system? Can you cast the entire planet as a self-organizing system? Like, I think even if we don't necessarily go all the way down to fundamental physics, etc., it can go so far up that I think it's interesting. Or at least for us, for the kinds of things we'll be studying for a very long time, I don't think we've pushed it as far as it can go.
And that's for sure. Like, yeah, as you mentioned in the paper, it's any system with a coherent locus of states or paths. And like, I don't know if you could say that about a rock at the moment, but you could probably say that about a community, a society, a nation. So that's fascinating.
Yeah,
all right,
absolutely.
Great. Thank you, Mahault. That was fantastic. Thank you for humoring me with a bit of the fun metaphysical questions. All right, so now at a very high level, just to start very generally, if you could outline to us, please, the difference that you see between the current more LLM transformer-driven paradigm of AI versus what you're researching, cognitive computing. What do you think are the main differences?
So they're kind of orthogonal in a sense.
Yeah, it has to be, yeah.
Cognitive computing is really just about understanding both the mechanism and the structure of cognition. So how agents perceive, infer, decide, and act in the world. And LLMs really are just a statistical pattern matcher trained to generate coherent sequences of text without an intrinsic understanding of the world. And so, cognitive computing partly is what leads you to building an LLM. It's like, how do we understand how the mind works? Let's apply this to a version of computing. However, cognitive computing is a very broad field, and as a field, we've sort of moved away. I feel like most scientists are saying basically LLMs are not going to lead you to AGI, and if you're still trying to create a cognitive system, you are more and more going towards the idea of agency. So the model has to have a model of itself and the world. It has to continuously update its beliefs, act autonomously. And so an LLM really isn't an agent. It simply generates responses based on next token probabilities. And so it doesn't really minimize uncertainty about the world or engages in adaptive reasoning. So while it could be, an outcome of cognitive computing, they're not a cognitive system in themselves. And so I think generally we are moving on from LLMs.
Well, what I'm trying to get here is, are there sort of qualitative or even categorical differences? And what I mean by that is like, okay, yes, completely, I agree that, it doesn't like reason, it doesn't really engage with the world in that sense. But like now, was it with I don't know, OpenAI released the chain of thought model, right? So, and they claim, I don't know much about what the work they do really, that it has a certain sense of reasoning built into it, because it kind of outlines its like steps as to how it arrives at an answer. I think when you prompt like ChatGPT, for instance, you even sometimes get like two decision trees, like where there's suggestion 1, suggestion 2, that sort of thing. But then I'm assuming you'd still claim that's not true reasoning. It's like a facade of reasoning. Again, because in this case, these agents aren't inactive. They aren't engaging with the world.
Yeah, no, exactly. So basically, in order to have a cognitive agent, you have to have an intelligence that emerges from a generative model that comes from interacting with the environment, dynamical systems that engage in planning and inference, continual belief updating, ideally via Bayesian or variational inference, but, ultimately it could be another way. You have to embed your knowledge within a model of the world. You have to have goal-directed reasoning under uncertainty. You need to adjust new information dynamically. But I think more than anything, what you really need is just beliefs about the world. And ideally, causal beliefs about the world, because otherwise you can't act on those beliefs. You can't do anything. So your predictions about the world have to be anchored in like a sense of, where are we now? Where are we going next? And where do I want to go? So there's a bit more here that LLMs just don't have. So one of the papers that was written by Carl Friston, which was called, let me look for it just a second. I had Googled it earlier just because I wanted to have it ready for you. But it's called From Passive to Active Generative AI, Active Inference as a Framework for Synthetic Agency. And basically, he explains really well that cognitive agents have to be self-organizing systems. They have to perceive, act, and infer. And so they have to have goals and beliefs and an explicit world model that they can navigate through sensory motor interaction with their environments. So cognition really is a sort of closed loop system of belief updating, action, and environment coupling. And it has to be ontologically grounded in the agent's structural coupling with the world, which, Carl formalizes via Markov blanket, but there could be other ways of doing it. And so LLMs just don't have that. Even O1, which does some degree of chain of thought really is just self-prompting. That's all it is. So it's anchored in itself, and that's a form of anchoring. It has a form of, joint distribution with itself, but ultimately that has nothing to do with the world. It has no beliefs about the world. It doesn't even know whether actually it did something or not. In order for it to know whether it did something, you'd have to add an extra thing on top that says, oh yeah, here's an input, you did the thing, now move on. But that, you see how now we're getting out of like this O1 system, and we're adding on pieces that give it this sort of closed loop, which gives it a sense of beliefs, which again, it just doesn't have right now.
Okay, so for a lay audience, Mao, can you explain what it means technically for a agent built on cognitive computing principles to have beliefs about the world? Like, how are those beliefs encoded in an agent built on the principles of cognitive computing?
How are beliefs encoded? You mean under active inference?
Yes, put it that way. It's fine. Yeah, I'm just talking broadly cognitive computing, but we're discussing your main field is active inference.
Sure. So the way we do it is probability distribution over latent states of the world. So basically what you have is, you have an agent and it has a sense of what it can observe. So you can encode things as like, one hot encoding, whatever you want. And so it will take in these observations. Let's imagine that I take in images about wheels or mice or sounds, for example, whatever. You take any sort of input. And you're going to try to map the likelihood of this observation having been caused by another hidden state in the world, which you don't have access to. All you have is what comes onto your boundary. So you have a belief about a hidden state, and you have a generative model that gives you the probability of that hidden state given this observation, and that gives you a joint distribution. And so that constitutes a belief about the world. It constitutes a sense of, here are two things, here are how they are connected, and here's the probability that they are connected, which means I could be wrong. Like, I have some evidence to that effect, but, some more evidence could make me sway, and I could think, actually, it's a different cause. That constitutes a belief.
Okay, so I'd like to discuss go on a bit of a segue here, or perhaps a bit of a tangential point here. The notion of representation. So I was reading one of my favorite papers by, in fact, my master's supervisor, Ines Hippolito. She and her authors of this paper called An Alternative Cognitivism, Computational Phenomenology for Deep Learning. And she kind of, they posit that the authors that, yeah, for a computational phenomenological system, they can have a non-representationalist model where they don't have this kind of, it's not like symbolic AI the way the kind of current paradigm of AI is done. Now, when you make the, for example, when I was thinking of active inference, you sort of have to be representationalist in the sense that you kind of need a model of the world, right, for you to update the model of the world based on the the invariance of the free energy. So for active inference agents, is it necessary for them to be representationalist, or can even it be built on kind of like what would be outlined in a paper like this computational phenomenology paper, where it's going to be non-representationalist as it pertains to the world?
So I am not a non-representationalist. I do believe that inactivism and representationalism can live in the same realm. And I think that's work that Axel Constant, Maxwell Ramstad have really pushed forward and made a good argument for. So to put sort of the pieces, basically representationalism means you construct an internal representation of the world and then you process it to generate perception. Seems pretty basic, but it has the tenet that perception is indirect. So the brain doesn't have direct access to reality. It creates models of it. That's very compatible with active inference because we are mediated by the Markov blankets, certain states of the Markov blanket. Cognition is information processing, and this is perhaps where the crux of the issue lies, where basically mental states and neural activity encode information about the environment in a way that can be manipulated computationally. And that basically learning is about improving those representations. And so under active inference, you'd say improve your model of the world, right? But essentially, you could see reality as consisting of joint probabilities across Markov blankets, which means that representations that exist but are always interacting dynamically with the world through this Markov blankets. And so you don't need to have an internalist representation, which means a classical symbolic AI, or an extreme anti-representationalist. Here we can really have a middle ground where representations exist, but they are probabilistic rather than static symbols. And cognition really just isn't about processing representations, but also negotiating them through interaction with the world. And so the brain doesn't just receive the world, it actively co-constructs it through these generative model. And so the representations are maintained, but they're structured by the active engagement of the agent with its environment. And they're not snapshots of reality, but they're really like probabilistic structures that allow for action and adaptation. So I think this really gives us some fodder to see it in a combined way. And as far as the computational account, manipulating these beliefs, right? These representations, these beliefs simply means changing the distribution for given beliefs, given new evidence, and thus potentially changing the paths. That's all that it means. So I think it's very compatible.
Yeah, thank you for clarifying that. As you saw, I couldn't even properly articulate that question because I'm still trying to understand, yeah, in fact, what it even means to be non-representationalist. Because even if you take this inactive account, an agent still has some kind of model of the world, right? Like, I mean, even in the paper where you guys map Husserlian concepts to active inference, like I'm still quite new to Husserl's phenomenology. I've read Merleau-Ponty, but even in this paper, you guys do discuss, I forget the exact term, that even in Husserl, you do have like a model of the world, like prior beliefs about the world, and that allows you to kind of engage with the world based on those prior beliefs. So I find it really hard that like how can you even engage in the world in the first place without any kind of belief? Like, I mean, this pen can't engage with the world in that sense because it's a pen. It's not an active system, if that makes sense. I guess the difference here would be more in the active approach, the active inference approach, that like you don't make any ontological commitments that like the world is like a static thing out there, hard thing, whereas it's more like you give like a more probabilistic account, isn't it?
Yeah, exactly. Yeah.
I see. Fantastic. All right, great. And now, again, to kind of speak of cognitive computing, I'd like to discuss a bit about the work that you're doing at Versus AI. I haven't looked too much into the company, but I'm curious. So, I mean, there are all these, AI companies. I'm sure you're getting a lot of VC funding and whatnot. But yeah, like what makes? Sorry, this will sound like a marketing propaganda question, but like, what makes the work at Versus AI different to what they're doing at OpenAI? Or Anthropic AI, for instance?
Well, so they're banking very hard on LLMs. That's one thing. I think they're banking on a technology which I think is intrinsically flawed.
You mean the latter? You mean OpenAI and
yeah.
Yeah, that makes sense.
Yeah. They're banking. I mean, Sam Altman basically thinks that LLMs are the path to AGI, and he's just going to put $500 billion in there, and yeah, there you go.
Yeah, I mean, he's kind of got to say that, right? Because if not, they're going to lose out on that sweet investor money.
I personally don't think that's the way. I'm sure at OpenAI, they have plenty other projects, right? But from what I understand of what's externally visible, they seem to be banking, Anthropic as well, they seem to be very strongly banking on this transformer-based approach, which I think has intrinsic limitations, which we're not going to get beyond through that technology. We can improve on that technology, but it's going to have to go through the kind of technology that we're building at Versus. So to give you a little bit of a sense, at Versus, we have a product side and we have a research side. On the product side, they're building Genius. They are building this platform that allows people to build their own agents. So you can build your own models, build your own agents. You can do what you want with them. We don't necessarily provide you with the model. We just give you the tools and you're fully autonomous. You do what you need. And you can use these principles of variational inference to navigate, for example, enterprise problems. On the research side, we have a sort of triptych approach. The first part of our lab is a mathematics and physics lab, which really looks at fundamental math and physics and basically the relationship between thermodynamics and information. That's the core of it, right? Then we apply that and we put it in ML and robotics. And so our ML lab and robotics lab tackle benchmarks like the Atari benchmark, like future robotics benchmark, like Habitat, for example. And we apply the ML tools that we've built to create agents that can actually act in the real world. And then our last lab basically takes all this technology and scales it to key societal problems like AI alignment, like AI governance, like sustainability. And so we basically look at, okay, well, what if you have all these agents? How do they interact with each other? How do they interact with us? How do we ensure that when they do, they're aligned with our values? How do we make sure that when they do, they don't destroy everything around them, like the environment, just not on purpose, right? Just like by virtue of being completely inefficient. Like right now, I think I read this somewhere. If you do a ChatGPT query, you're using 1 bottle of water. That's insane. That's insane. We can't go on like this. We can't just scale, right? So we have to find ways to...
I didn't know that. Yeah.
Right. To bring intelligence like what we do with the human brain. We have to go, biomimetic as much as possible.
Yeah, so I mean, I know there's like I didn't even look it up, but I probably should have done before the interview. It's called Genius. Like there's a beta sign up page and all that. So can anyone just like create a beta account and interact with this? It's more like an AI agent building platform, right?
Yeah, exactly. So the beta program means there's a selection process. We can't help everyone all at once. So we have a selection process, and if you do get selected, you can use the platform and give us feedback on, how well you used it, or were there things you would have wanted to see, was your use case actually possible to tackle with our platform. So that's how the beta program works.
So let me ask again, more of a product. I mean, this makes sense. You're a director of product, so product engineering based question. But like, what kind of agents can people currently build? Like, would it is like what kind of? Let's just discuss what kind of use cases for businesses would they have with Genius.
I mean, you can build anything so long as you understand the structure of your problem. If you have an expert in your domain, you can build any model. We can currently build POM DPs, NDPs, so this kind of thing. You can build any sort of Bayes net. So if you are within those problems, you can easily create an agent. So any kind of optimization problem is a problem you could solve. I currently just came back from London where we presented a demo called EcoNet. And basically it was a multi-agent, self-organizing smart home where the goal was for the agents to help you manage all the appliances in your home and your energy sources such that you would reduce gas emissions and reduce costs, as well as maximize the preferences of your users. So that's, for example, just one of the use cases you could tackle with our platform. So it's really up to the user to figure out how they might want to tackle their problem with an agent architecture. I think that's the core of the question.
Makes sense. All right. Just discuss the engineering viability of what you guys are building. Like, again, I talk here as a complete outsider with no insight into what's being built. Like, for agents, or like, let's say the kind of the work you're doing, active inference-based AI, does it require some kind of fundamentally different architecture, both software and hardware, or can they be built, would you say, I mean, what you currently have, but also as you develop and advance this product, or let's call it a suite of products, is it going to require some kind of fundamental change in computer hardware and software and architecture?
So there's multiple ways to look at this question. The first way to look at it is, in order for agents to be efficient, they have to be able to communicate. And in order to communicate, ideally, you want to have a minimal overhead. So you want some interoperability layer, and you want some safety in the communication protocols. So we have something called the Spatial Web Foundation, which is a nonprofit, and they are developing a spec with IEEE, and they are basically trying to put together what the standard might look like for different agents to be able to communicate. So if you're curious about that, you're welcome to go and take a look. It's a very big spec, so it's a read, but it has some interesting components. Then there's some people who are very into, in order to have multidimensional composable domains, i.e., I don't want to pre-create every agent ever. I want to create agents or seeds of agents that are able to sort of transform themselves into what is required for a task at hand. So basically just compose. Some people think that you need to think in terms of category theory. So there is budding research in that field. And then I feel like if we want to have agent-based architectures, we may want to think more and more in terms of factor graphs, like how can you translate beliefs? How can you share them around? So that's another way to look at the question from the perspective of what might be the required architecture and technology. As also one thing that you need to consider is, as I said, all of this is extremely computationally inefficient. It's a lot of energy. And we're going to come upon this von Neumann bottleneck where unless memory and compute are together, at some point you're just going to hit a wall. And so neuromorphic hardware might be the solution because it'll allow us to do things much, 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 much more efficiently. And if you combine that with neuromorphic software like active inference, you may get such an efficiency gains that now you're talking on the level of actual human processing, and you may be able to have agents everywhere that are easily scalable. So I think those are the different
I
parts.
think it's thanks to versus or some. I forget. I saw on LinkedIn this term use neuromorphic hardware. Yeah, do you mind? I'm so glad you mentioned this, Mao. But like, what's neuromorphic hardware? I mean, is it something that exists, or is it something more theoretical at the moment?
No. It exists. Like, for example, the Spinnaker. It's a neuromorphic chip that basically works with spiking neural networks. And it's really cool. And so, for example, again, in London, I was at the AI UK demo, and we were speaking to this lab from Sheffield who was applying neuromorphic hardware to all kinds of problems. And they were doing this with incredible efficiency gains, like just like a fraction of the energy required, or even the compute. Like, they were doing it all online, basically. So it's a promising avenue of research. I think if we can combine active inference and neuromorphic hardware, we can really get somewhere very cool.
That's brilliant. Yeah, thank you for sharing that. I probably look it up. I didn't know much about this. Again, should I prepare better for this interview? But that's great. Afterwards I'll do some Googling. And the company said was it Spinnaker?
Yes. So the neuromorphic hardware is called Spinnaker. Spinnaker.
Cool. Yeah. Awesome. I mean, yeah, and I should mention that I'm sorry for the almost tried cliche comment, but amidst the climate crisis, certainly computational efficiency is something we need to. It's not just a nice thing to have or a nicety, rather an ethical imperative, let's say.
Agreed. Completely.
And I didn't know about this whole thing where, did you just say that generally speaking, one prompt takes the energy of one bottle of water or something along those lines?
Yeah, I read that. So again, take that with a grain of salt. I couldn't back it up with a source, but I did read that, and I was like, holy crap.
Yeah.
That's intense. And I honestly believe it. Like, their model is not sustainable in any sort of way. It's not financially sustainable. They're not making profit. It's not energetically or environmentally sustainable. They're using so much water just to run their data centers. So we got to find a solution.
Yeah. I apologize for the rant, but like, I've in fact unsubscribed from, I did it about a few months ago, from all like the AI tooling, removed GitHub Copilot from my editor, because it's like, I mean, my day job, I'm a software engineer. I just realized that actually using my brain's a lot easier than, this so-called prompt engineering, because most of the time the code they spit out isn't that useful, and it's stuff I could already find like on Stack Overflow or wherever, which just makes sense given that's where they pull it from. So it's a highly optimized search engine, really. But no, that's exactly why I wanted to have this discussion more on active inference AI, which I find to be quite a fruitful terrain. Excellent, Mal. So, okay, now I want to pull you in again for a few. Oh, actually, no. Before that, there's something else I want to mention or ask from you. I'm glad it hit me at this moment. In one of your interviews, and I'd like for you to kind of flesh out this point a bit more, you kind of made this passing comment that with active inference AI, we wouldn't even really have an AI alignment problem. This was about a year ago, so you probably forgot that comment. I'm curious, like, what do you mean by that? Because I mean, AI alignment, there's so much, thought going into it. Everyone's talking about it. But you said that with agents built on active inference framework, AI agents, it probably wouldn't even be an issue, this much of an issue as we're making it right now.
You still have to consider, right? Because you're basically, let's assume you get to something that resembles sentience. We just recently put out a paper that says sentience has very simple components. You can't measure it internally, but you can measure it externally. You can measure its outcomes. And if you do, then some systems, non-natural systems, may possess sentience, or at least a very rudimentary version of it. So what happens when you deal with a sentient system that basically self-organizes and tries to maintain itself, right? Because that's what it is. It finds ways to maintain itself. Now you have something that has a stake in the game, right? So if you have something that has a stake in the game, how do you make sure that that thing does what you want? Well, the truth is you don't. You can't make sure. You can try to create structures around it, right? That's what we do with laws. That's what we do with weapons. Like, we have structures to sort of force the thing to do what we want, like, which is the same for us, where we force the thing. But there's also internal drives, like, why aren't you mean to me right now? There are lots of reasons why you're not mean to me right now. One of them being empathy. It literally doesn't feel good for you to make me feel bad. There's the incentive is lowered when you do that. There are other incentives which could be stronger, but if there's no competing incentive, you'd rather not be a dick, right? So that's one of those things. You also have other drives like acquiring information. You want to know more about the world. You may have utility drives. You want to acquire something from people. So all of these drives, and the fact that you are an agent that is trying to understand more and more about this reality, that agents ultimately try to find, an attractor around which they can stay, that they can sort of exist in metastable states around a sort of, a distribution that seems to be promoting what they are as a phenotype, given a harmonious relationship with other things around them, which constitute their environment. You quickly get to a point where your agent will just naturally sort of align with its environment, because it becomes joint with its environment, and it sort of integrates the mores, I guess, or the projection of the environment onto the agent. But that also lends us to, pulls us to another question, which is, what are the conditions under which a system like this might not be aligned? And those are the same as a human or any other sentient thing. Like, for example, I was listening to a talk with Ben Gio, and he was saying that AIs should remain subservient, and in order to do that, we should make them enjoy suffering for us. And I was just baffled. It's like, we've learned nothing. We've learned nothing of thousands of years of oppression upon other groups, which we have decided to subjugate. Like, somehow it's not like, obviously, if you do this to a sentient entity, if you place it within a subservient, subjugated position, just didactically, it's going to be in this kind of adversarial, just ontological position. So maybe let's not do that. Maybe let's reflect on the way we consider the things we create and how we place them in society. I think the alignment problem will have less to do with optimizing some kind of reward function and more to do with understanding how we literally place things within a framework that forces them eventually to push back against the framework.
Yeah, that kind of AI, I think that Derrida would call it phallogocentric AI, where you want the AI to suffer for us and make them our slaves and that sort of stuff. I mean, haven't they, looked into the history of colonialism and whatnot, huh? Whole other conversation. But now I can see what you mean by that notion of agentic AI. Yeah, thank you for correcting me there. You didn't say we're not going to have to be worried about AI alignment at all, but at least we can shift the way we approach that question, given now at least if there is this kind of agentic AI that be engaged with the world. And you're right. I mean, look, if you're building AI agents based around human cognition as to how we engage with the world, but human beings are also really bad at empathy. It's not that we're good at empathy either.
I think that's partly like these illusions, right? Like we have these illusions about how the government works and what makes someone do something. And ultimately, you sort of internalize certain superstructures, and you assume that because they're internalized, they're just going to work. But then there's one that doesn't internalize them. And then he sort of breaks the illusion that they work. And so you get someone who just decides to, for example, take the law into their own hands and realizes, oh, I can actually do whatever I want. There may be consequences, but I can. Because the mechanisms in place really only affect people who have the certainty of certain kinds of consequences. And ultimately, it comes down to force, right? It comes down to force. So this is why your question about the embodiment of agents, I think it will be important. It will be important because in order to have a governance system, you have to have a stake in the game. It has to be possible for you to live through a form of consequence. Otherwise, yes, empathy only goes so far, right? Like empathy does fail. People do get murdered. People do get stolen. And sometimes even it goes through shutting down your empathy towards certain people. Doesn't mean you don't have it. It means you shut it down in order to be able to live your life because you've justified it to yourself through X, Y, Z kind of mechanism. So, I think we have to think beyond just let's make sure that the AI is air-gapped, because, hackers have shown that you can social engineer anything, but also that not just social engineering, you can literally control a system beyond air gapping. So, I feel like the sociological questions will truly be the right path rather than a purely engineering focused question.
No doubt. I'm in complete agreement. Which is why, again, to revisit that previous, at the outset, the way we started the conversation, this whole thing of, calling the humanities, so-called the soft sciences or whatever, it's nonsense, because, the humanities are deeply empirical too. They're based on what you observe. It's empiricism, and you can verify it based on other phenomena you observe. So, it's a whole other can of worms. But I'm sorry, another bit of a tangent here, but what you mentioned, stake in the game, that's so important, and that's kind of why I was initially drawn towards active inference work, because you could see implicitly that it's already there in the kind of the stake in the game notion. I was just listening to this. He's great. The British. He's a inequality activist and economist, Gary Stevenson.
I love that man.
He's fantastic.
Shout
right?
Gary. Oh my God.
Shout out Gary. I feel like he's just all time, goat. And he makes this point, he's like, okay, look, we're in a pretty bad place, working class, we're and then he's like, but the rich are going to be okay. And that's where I think I disagree with him, because he's still calling to for the rich to have this empathy and but I think actually the thing is, if society crumbles, the rich also are going to be in trouble. No one can escape this thing called humanity as much as they try. No one can escape the social. We are all caught up in it. We all have a stake in the game. And I think he should change the wording and not try to tap into empathy, and rather be like, hey, look, if the majority of people suffer, if majority of society just crumbles, you're screwed too. So
that's a really
connects to the notion of stake in the game.
No, you're completely right. And in fact, I just watched a show. I think it's a British show. I'm not sure. It's on Netflix. It's called The Decameron. Have you watched it?
No, I haven't. No, I'll add it to my list too. Yeah.
So it's a very silly show, but it has some depth to it, where it basically talks about Italy during the plague, the Black Plague. And it's basically these rich nobles with their servants who decide to escape the plague on a holiday, and they go to this beautiful villa, and just, they're rich, so they can escape the plague while everybody else is dying and starving. And ultimately, no, you can't, because you're dealing with other humans who have feelings and who are, they're not that compelled to do what you want if you lose the superstructure that allows you to maintain your power. So I think you're correct. There's a degree of collapse after which, the elite will no longer be able to sustain itself. I think Gary's point is we're quite a ways away. Like, lots of people will suffer for a long time before the 1% feels the brunt of it.
Yeah. It's like the collateral damage will be it'd be so morbid and tragic, and it'd be terrible that before it even touches the elite and the people in power, the powers that be. Excellent. Okay. So just now, since we're talking about kind of more of like political philosophy and whatnot, I kind of want to touch on again the philosophical side of things. I think you did outline quite well the cognitive computing and the fundamental concepts there, some of the concepts or principles at least. But I'd like to discuss this paper, Mapping Husserlian Phenomenology onto Active Inference. Great paper. I thoroughly enjoyed it. Learned a lot about Husserlian phenomenology too. But this notion of mapping, I'm curious if you guys have thought about this. Like, so I'll give an example, right? One person that I also really enjoy is Mark Solms, the psychoanalyst. So one thing he's trying to do is, he's been trying to do this for a while, and perhaps he was some kind of a pioneer at this, is kind of bring these concepts from Freudian psychoanalysis, which is not a science. It's more like a philosophy, or like a way you view the world, and try and like make it port those concepts into like more neuroscience and cognitive science, right? So like through like brain states or whatnot. And then I've always wondered, like, when one does this sort of mapping from two ostensibly at least different disciplines, different ways of different, even let's call it epistemologies, let's say, to a certain extent, what do we miss out on? So like when you I don't know, port the notion of the unconscious, let's say, in psychoanalysis to more of like to the language of neuroscience, is there something that we miss out on? And then that's what got me thinking here regarding mapping Husserlian phenomenology and onto active inference. Firstly, I'll probably ask this question in a bipartite manner. Firstly, what is it? Why is this mapping even necessary, in the sense that what does Husserlian phenomenology, in your opinion, have that active inference doesn't have? And secondly, have you guys done a bit of thinking as to what you lose out on when you do this like one-to-one mapping in this type of formalization of Husserlian phenomenology? Sorry, I know that was a lot there, but
it was a lot of questions. Yeah, so I'm going to start, and then you can tell me which question you'd like me to tackle.
Maybe we'll go with the first one, which is like the what does Husserlian phenomenology have that active inference doesn't have?
Okay. All right. So Husserlian phenomenology basically speaks to phenomenology. That's something that active inference fundamentally doesn't really have. It speaks to qualia. It speaks to time. It speaks to some extent of memory. These are things that, while present in active inference, are not explicitly decomposed. So, for example, Husserlian phenomenology really gives you a descriptive insight into how conscious experience is structured, right? So you can use active inference to speak to how consciousness is structured, but it's not intrinsic to active inference. You still have to gather these insights. So, for example, Husserl did a lot of work on time consciousness, intentionality, intersubjectivity, and that's why the paper that we wrote on shared pretensions was trying to leverage this and a paper on Husserl, right? We were really trying to think about the way that consciousness is structured in this sort of bipartite way towards this middle place, the oppressions, and how this gives you a causal structure, and how information is then experienced relative to that structure. But what active inference gives us, which isn't really present in Husserlian phenomenology, is, well, Bayesian mechanics for one thing. So a true mathematical principle that allows you to understand how these things both are connected and shift. So it bakes in perception, action, belief updating, and it's framed in terms of free energy minimization. So you have a mechanism by which you can understand how someone learns, how they update, etc., which is not necessarily present formally under Husserl. And it gives you this sort of predictive machinery for how the agents navigate uncertainty and maintain self-evidencing model, which again, there's none of that in Husserl, right? That's not really present. So yeah, have I answered the first question?
Absolutely happens. So it's consciousness, right? Like it's just, yeah, that makes sense. I mean, yeah, I feel like I don't want to get too much into consciousness because it's like all of these conversations ultimately lead to that. And I feel like you've done a lot of interviews on it. But then on the notion of, the mapping, this is where I think in like a very long-winded way, I brought the Mark Soames example, science or neuroscience and psychoanalysis. Yeah, like in this mapping, do you think there's something that we lose out on from the insights we gain from Husserl's phenomenology, or do you think like it's beautifully, perfectly isomorphic?
So I think there's always a form of loss, but the question is to what degree and what it lost useful for the purposes with which you're going to use the second mapping. But so like the principles underlying cognition are sort of substrate independent, right? So we can think that you basically use you generate and maintain beliefs about the world, predict sensory outcomes, you act to minimize, and so that's not something that it doesn't matter what you map it onto. But basically, generally when we speak of loss, we speak of ambiguity. So, like, how do you capture nuance, right? How do you ensure that you're not too strict in your measurement? You want to have modal flexibility, where concepts can be possibilities, right? As opposed to just empirical facts. And you want to have a degree of scope of abstraction where the phenomenological claims about experience sometimes can be difficult to express in quantitative terms, right? So that's something that phenomenology gave us. But what we gained, in contrast, is this operational clarity and the ability to integrate it across domains. So now, while we may have lost a little bit of abstraction, we may have lost a little bit of flexibility and some degree of ambiguity, because we lost this ambiguity, we're able to have this possibility for empirical traction. So I do believe that to some degree, some things are lost. It's not just that philosophy to science, you lose something. It depends on the type of philosophy, right? I think when you go from continental philosophy to a more scientific, empirical practice, then a lot can be lost, because the prose of philosophy, the way that they try to create a concept in continental philosophy, or at least in the more modern versions, it's about forming an image in the mind of the reader. It's not always about a formal proof. Whereas if you went to analytical philosophy, for example, I don't know that you would lose anything. They're using the same language. They're using the same approach. If you went under just logic in general, I don't think anything's lost either, because it is the same language. It's the same hardness of the concepts. And so because the concept is hard, it's easy to know what it is and what it isn't. And so if you know what it is and what it isn't, you can easily map that to another language where you also know what it is and what it isn't. And if you have to add a nuance, you just, sort of tweak or recompose the concept. So I think some things are lost, but they are things which I think we can abide by losing because of the probabilistic nature of active inference, which allows us to not be so harsh. And because the framework is so simple, it can also be very expressive. So there is a degree to which you have some flexibility with it.
That makes sense. I mean, just to clarify, the reason for me asking that question was not because I think this sort of mapping shouldn't be done or it's impossible. In fact, that'd be a asinine question, given that for the past 100 years, applied, Dan Zahavi has written quite a lot on this. Applied phenomenology it's been psychiatry to social psychology. So it's been applied to many fields other than like pure philosophy. And therefore, why not even do it for more, AI and active inference? It only makes sense. And given all the discussions we were having about kind of the ethical problems of the qualms with current AI, why not use this rich tradition of phenomenology to see what we can, map onto the current work we're doing? Beautiful. I mean, and I'll just say this, perhaps this is the penultimate question, Mahault. Like, the reason I also asked this question was because, like, in fact, one of your collaborators, Jeffrey Yoshimi, he's written like a lot of papers on the notion of like naturalizing phenomenology or mathematizing phenomenology. And then he had one of his, I think this was the Routledge book on, let me look it up. It's called Prospects for a Naturalized Phenomenology. I was just reading this recently, and like he mentions that, like Husserl and his successors were critical of this notion of, they were opposed to naturalism. So they did have certain, they were a bit skeptical of naturalistic phenomenology, but that doesn't mean, they aren't like, I don't know, they're not like, they're not like gods or anything we need to listen to, right? Like we can develop on from there. It's not like it's set in stone, whatever they said about phenomenology.
Yeah, and besides, I mean, there's a lot of prominent philosophers who believe in that project of naturalization of phenomenology. Like, for example, Francisco Varela, Evan Thompson, Sean Gallagher. They argue that the phenomenological methods can inform cognitive science and vice versa. So the crucial part is really how much you lose, and making sure that whatever you do lose, you're able to maintain somehow through, continuing to study the core phenomenological philosophy and figuring out eventually how you might reintegrate what has been lost. Because eventually, I mean, ultimately it's about translating as much as possible. There's always something lost in translation, but there are translations that are as accurate as you could ever get, right? So eventually you'd lose so little that you might as well use the formal language. So if you identify elements which have been lost in a given translation, that's precious, because then we can be like, all right, that was in fact lost. It says something both about the structure of consciousness that's valuable intrinsically, but also it says something to, okay, well, this is maybe where we need to push the next scientific endeavor to have more of a sense of how we want to now develop our mathematical formalisms or other kinds of languages and translations that we can use to make predictions about phenomenology.
Yeah, no doubt. Yeah, perfect. That was very cogently put. Thank you. So, all right, Mahault, last question. I mean, you're currently doing a PhD on cognitive computing. Tell us a bit about kind of like what you're currently doing. What are the big questions you're tackling in the field of cognitive computing? And if someone wants to get into this line of work, this line of research, what are some fruitful areas in your opinion?
Yeah, I mean, so my work is really trying to get to the core of intersubjectivity and how meaning arises from experience. So what is the relationship between materiality and information, and how that construction ultimately says something to what we project, and how those projections interact with each other. And that can be useful in a variety of ways. For example, you could do opinion dynamics, like the work we did for epistemic communities. You could try to predict how people are going to vote, but you can also do things like understanding what a given word will mean to different people, and how that will affect them. And so you could try to see, well, okay, what if I wanted to get people to help for a certain project? How might I phrase that? How might I pull on certain things? How might I change their mind? So those are the kinds of things that you can do with the work I'm looking into. And that has implications for AI alignment as well, right? Because if you understand how meaning relates to, the relationship between information and materiality, then you also understand how any given system will probably act given a form of meaning, right? And so you can sort of pull on certain threads with any entity which has this kind of graph-based architecture, for example. We will be presenting such work at the next IY. I don't know if you're aware of the International Workshop on Active Inference, which is...
Yes, I am. Yes.
It's happening in October in Montreal this year. And applications are open, so people can already put in their paper if they want. And they can buy their ticket if they want also. So it's on the GitHub for IY 2025. And if they want to get into the line of work that I'm doing, that's really the best place to go, because you're going to be speaking to industry people, to academic people, to students and professors. So everyone from the community is going to be there, and you can both speak to their projects, the kind of things they're interested in, the kind of things the community is working on, but also just promote yourself and talk about your expertise to people who might be interested in hiring people. So
excellent. And for those of us on the other side of the world, will it be streamed anywhere online, or is it an in-person event only?
It will be streamed. We can definitely stream it. That's not an issue. We prefer in person just because it's really a community event. It's meant to get people coming, but we will have recordings available for sure.
Perfect. In any case, I'll find the resources and put in the show notes. But now, thanks a lot for your time today, Mahault. Again, huge fan. Love following your work. We'll be keeping an eye on your Google Scholar to see what other publications you guys come up with, you and your fellow travelers. But yeah, thank you for your time today.
Awesome. Thank you.